We are discussing chapter number 10, which is visualizing solid shapes. So we have learned about the plane shapes and solid shapes. Plane shapes have generally two measurements, like the length and the breadth. For example, this rectangle has a length and a breadth. And if we have three-dimensional shapes, that is the solid object, then it may have length, breadth, and also the height. Why I said may? Because the solid shape comes in various categories, like a cylinder. Cylinder is also solid shape. Cone is also a solid shape. So a solid shape and a solid object occupies some space also. So you can just say two-dimensional as 2D and three-dimensional as 3D. So triangle, rectangle, circle, they are 2D figures, while the cubes, the cylinders, the cones and the spheres, they fall in the category of three-dimensional figures. Let us match these. This is a two-dimensional and it seems to be a square. Then this is a cone. So it's a cone. Then this is a cylinder. Just mark it, cylinder. This is a cylinder. Then we have a triangle. This is a triangle. So this at the last is the triangle, and this one is a cube. It's a cube. This one is a cuboid. This one is a circle, right? And this one is a sphere. This one is a sphere, the first one, right? This is 2D, 3D, 3D, 2D, 3D, 2D, 3D and 3D. And in practical life, there is a combination of different shapes. See, this is a tent, but it is a combination of a cone and a cylinder. This is again a cylindrical shell. This is a softie, which is an ice cream, which is surmounted by a hemisphere. This is the photo frame. We have various, in fact, two rectangular area regions, you can say, and we have a rectangular path. This is a bowl, a hemispherical bowl. This is a tomb on a pillar, which is actually a cylinder, which is surmounted on a sphere or a hemisphere. This is a hemisphere, and you have a cylinder here. So let us match this. First of all, agriculture field. This seems to be an agriculture field. Then this is a groove, so this can be a groove. This is a toy. This is a circular part. This is a cross path. So this is an agriculture field. So let us match this. Two rectangular cross path inside a rectangular part. This is the matching. Then a circular path around a circular ground. This one is the correct answer. Then a triangular field adjoining square field. A triangular field adjoining square field. So this is a triangular field which is adjoining a square field. Then we have a cone taken out of a cylinder. This is a cone which is taken out of the cylinder. Then we have a hemisphere surmounted on a cone. So this is a cone and this is a hemisphere. Views of 3D shapes. So 3D object, if you see from different position, they look differently. They don't seem to be exactly same as against the 2D versions. So they have different perspectives. For example, if this is a hut, if you see from the front, it seems like this. If you see from the side, it seems like this. When you see from the top, overhead, it seems like this. This is a top view. A glass, when it seems from any side, it looks like this, but when it is seen from the top, it is different entity by itself. It's a different perspective. Then this is a brick. This is a front view of the brick. This is a top view of the brick. See, this is the top view, and side view is of course like this. So front view, side view are same, but the dimensions are different. Here we have a proper two, so you can say two rectangular regions are being seen here. Then for any cube of this sort, if front, you see from front, these three will be seen, so this is the front view. If you see from the side, only these two faces will be seen, this is the side view. If you see from the top, this one and this one will be seen, this is the top view. When a shape is like this, then top view will be, you see these two, if you see from the front, these two will be seen. If you see from the side, 1, 2, 3 will be seen. This is a solid made of 4 cubes. So this is the side one, you see only this one and this one. So there are only two faces. If you see from the front, 1, 2, 3 will be seen. If you see from the top, 1, 2, 3, 4 will be seen. Mapping space around us. Whenever we are dealing with maps, where we were taught in the primary classes, so there are and in real life also, we need to locate certain places, like say a particular river or a mountain on a map, and we have historically seen this to be done. In the historians they trace routes of rivers, road, railway lines, traders and others. So this is the basic building block of everything around us, like the Google Maps we see today. So how do we read maps? How do we understand the map? Then how do we get the information from the map which we don't have? Is this anything like a picture? So this is a house. So this is a house, it's a house picture. Now if somebody has to build it, or if somebody has to make it, the map, or it has to be shown in some map. You cannot show a house like this, because there will be number of houses there. So you can just show like this. See, this is the part, this is the tree shown in a small picture. So you can say it's a top view, and all these are being shown like this. These are different. This is a part, this is the entrance. So this is also the entrance to the first gate, second gate, entrance. And what we conclude from this figure, when we draw a picture, we try to represent reality as we see the detail. But when we go to map, we depicts only the location of the object, which is in relation to other objects. And for picture, different person will have different perspective, different opinions, depending on the position and from where they have a look of that house. But in the case of map, this is not true. The map of the house will remain same. Any observer, what he or she sees, it will remain as it is. What we want to emphasize here is that the perspective is very important for drawing a picture, but perspective is never relevant for a map. Now let us look at this map, which has been drawn by Raghav, which is just 7-year-old, and this is a route from his house to his school. So this is his house, and this is his school, and this is his sister's school. So what he does, Raghav, he made this house, but if I am to ask you, how far is Raghav's school from his house? Will you be able to tell? Not really. Would every circle in this map depict a roundabout like this? This circle, this circle, this circle, right? This circle, because there are various circles. And whose school is nearer to the house? Sister one or Raghav one? So from this, what Raghav has made, it is difficult to understand and answer these queries. Why? This is because we do not know if the distance has been drawn properly, or the circles are roundabouts, or they are representing something else. Now, Raghav's sister made the same map, who is 10-year-old, she is called Meena, and this is how she made. Now this map is somewhat different from what Raghav has made, and Meena actually used certain symbols. She showed the symbol which is called as a legend, L-E-G-E-N-D, legend, and the longer line segment for longer distances she has shown, and shorter line segment for the shorter distances. That is, she has scaled the map, or you can say she has drawn the map to the scale. Now you can say Raghav school is farther or shorter, means whose school is farther. You see, this is half kilometer, this is 1 kilometer, and this is another half kilometer. So it goes half plus 1 plus 1, half, sorry. So it is 2 kilometer. But when you want to reach Meena school, this is half and 1. So 1 and half, 1 plus half, that is going to be 1 and half, that is around 1.5 kilometers. Whose school is nearer? This much is the distance of Raghav school, and Meena school is nearer. And what are the important landmarks on the route? See, we have houses, different houses here. We have different shops here. We also have these are schools, of course, and these are the you can say different, post office, and here is a small lake. This is how it is being shown. So these symbols became very important. Also, mentioning the distance has really helped this map to understand, and the distance are proportional, and Meena has used proper scaling for that. And for a particular distance on the map, she has shown what is actual, means actual distance. She has proportionately shown the distance on the map, right? First of all, the larger the place, the smaller the size of the map which is being drawn. If you draw a map of, say, India, it will be the content will be very smaller. But if you want to draw the map of, say, your city or say your community, then it will be smaller. Means the map will be showing more stuff. Smaller, I just reference to the scale. So the greater is the distance. We can summarize here that the map depicts the particular location object in relation to object spaces. For map, I am saying symbols are used in order to show, depict, represent different objects and places, and there is no perspective or reference in the map. The objects that are closer to the observer are shown to be the same size as they are farther away. For example, see here. If you are driving, then you see like this, right? But in the map, this is the route, and all are being shown in the same way. So map use scale, that is the actual distance in the denominator, and the distance on the scale on the map. So distance on the map divided by the actual distance is the scale. So map uses a scale which is fixed for a particular map. So it reduces the real distance in proportion to the distance on the paper. Faces, edges and vertices. Now these are certain solid. These are edges, these are faces, and these are vertices. See, these are the faces, these are the vertex or vertices, and these are the edges. 1, 2, 3, 4, 5, 6, 7, 8, like this. So each of the solid is, of course, you might have seen now, they are made of polygonal region, and we call them as faces. And when these faces meet, they make a edge. For example, this is a face, this is a face. When they meet, this becomes an edge, and which are actually the line segment. And when the edges meet, see, this is a edge and this is the edge. When it meets, then this becomes a point. So therefore these solids are called as polyhedrons. These are not polyhedrons because they don't follow these properties. The polyhedrons, how they are different from non-polyhedrons? Because see, we ought to have the edges and the vertices, but here we have a round shape. That is why these are non-polyhedrons. Convex polyhedrons. Now if you happen to join, say, two vertex, this side or this joining goes out of the solid. If I join these two, this goes out of the solid. If I join, say, these two, it remains inside. But in this case, if you join any two vertices, the diagonal, or you can say the joining line segment, will always be inside. So that is why these are called convex polyhedrons. These are not convex polyhedrons. Regular polyhedrons. The polyhedron, they are said to be regular if the faces are made up of regular polygons, that is, all the sides are equal, all the angles are equal, and the same number of faces meet at each vertex. Each vertex should have similar or same number of faces. So this is a polyhedron, which is a regular polyhedron. The faces all are same, that is congruent, regular polygons, and vertices are formed by the same number of faces. This is not a polyhedron which is regular. So all the sides are congruent, but the vertices, these are not formed by the same number of faces, because 3 faces meet at A, say this one, 1, 2, 3. But at B, we have 4 faces, 1, 2, 3, 4. 4 faces are there. And they are various important members of polygon family. These are prisms and these are pyramids. So these are prisms. These are the polyhedron whose base and top are congruent polygons, and whose others are faces. The lateral faces are parallelograms in shape. While in this case, pyramid, it is also a polyhedron whose base is a polygon. It can be a square, it can be a triangular, but the lateral surface, they are triangular, you see, and they have a common vertex. A prism or a pyramid is named after its base, because this is a rectangular pyramid or a square pyramid, and this is a triangular pyramid. So what we have discussed: how to recognize 2D and 3D objects, how to recognize different shapes in nested objects, and 3D objects from different positions, they have different views. A map is different from picture, because in picture we have different perspectives, in map we don't have, we follow a scale. Map will depict or represent the location of a, say, some object or a place in relation to other objects and place. And symbols called the legends are used to depict the different objects and places in the map, and there is no reference or perspective in a map. The maps involve a scale which is fixed for a particular map, and this is simply the distance on the length on the map divided by the actual length on the ground. For any polyhedron, this is a formula. This is Euler formula. This F stands for the number of faces, V for the vertices, and E for the number of edges. So F plus V minus E will be equal to 2. This is Euler's formula. So this is all about this chapter. Thank you so much and take care of yourself.